In this section, the author is talking about how some compounds really just aren't very soluble in water. And he is going to talk about precipitates, and so when you mix two solutions together, sometimes you end up with a solid that's being formed. I actually showed you an example of that a couple of chapters ago in a video where it looked like I had two very clear solutions. I dumped them together and then it formed a precipitate. So what we're looking at is the chemical reaction for when that happens and how to write and balance the chemical equation for that. When he does example 9.1, he balances it for you, and the explanation that he uses is perfectly valid, but there's a little trick that you can use to make balancing these equations just a tad bit easier. And the way you can do that is to look at the polyatomic ion as a whole and not look at each individual element. Now, you have to be careful when you do this to be sure that the reaction hasn't somehow torn that polyatomic ion apart and reconfigured it on the other side. But in everything that we're going to be doing in this chapter, the polyatomic ions are going to stay together as a unit. So this is the same equation that he used in example 9.1. He took sodium carbonate, mixed it with aluminum nitrate, and came up with aluminum carbonate and sodium nitrate. So as you can see, the carbonate is all together over here, and the nitrate that was present here is all together over here. So in place of looking specifically at just the carbon or just the nitrogen, if I look at the nitrate as a group and the carbonate as a group, it makes it a little bit easier to balance. So let me show you what I mean. Here, my sodium carbonate has two sodiums, and I don't have two sodiums over here, so I'm going to put a 2 in front of the sodium nitrate. Okay? I have one carbonate, and over here I have 3 carbonates. So I'm going to have that balance, so I'm going to make 3 carbonates over here. Uh-oh, what just happened? Well, I did have 2 sodiums, but now I actually have 6. So that means I'm going to have to come over here and change this number that I just put over here. That's why you should always balance equations with a pencil, because that's going to happen sometimes. We talked about that when we're balancing equations as well. So now I have 6 sodiums, so I'm going to put that in front of here like this. If I compare my aluminums, here I have 1, here I have 2. And so if I put a 2 in front of here to balance my aluminums, what's that done to my nitrates? Well, I've got 2 times 3 is 6 nitrates on this side, and I have 6 nitrates on this side. So what you're doing here is you're looking at the polyatomic ion as a group in place of breaking it down into individual elements. So really that should make it a lot easier to balance these equations. Okay? Let's do a couple more as an example, and these are on the sample problems that I sent you as a separate document. So if you don't have that, you may want to pause the video and go get it if you didn't see that it was there and you need to pull it back out. The equations are all right here. I have them written all up on the board already. So what we're going to do, we'll do this first one together, and then I'm going to let you try the next 2 yourself. So I've got barium nitrate and sodium hydroxide, and as we talked about before in a double replacement reaction, really what they're going to do is they're just going to kind of swap partners. So I'm going to take the barium and I'm going to put it with the hydroxide that's over here, because this is the positive ion, this is the negative ion. So they swap partners. So I have a barium that's going to go with a hydroxide, and this is where you have to remember your polyatomic ions. Hydroxide has a -1 charge. Barium is in the second column on the periodic table, so it has a +2 charge. So in order to make this balance, I will need 2 of those. If you're a little rusty on that, you may need to go back to the end of the last chapter and review some of those problems that we did where we were writing formulas for these. Your other product is going to be the sodium from here and the nitrate with here from this other side there. So the sodium and the nitrate are going to go together. Sodium's in the first column on the periodic table with the +1 charge. Nitrate, you should have memorized, has a -1 charge. So the formula for that's just NaNO3. Okay, so I've written my products. Now I'm ready to balance. I have 1 barium on each side, so that's already balanced. I have 2 nitrates here, so I will need 2 nitrates over here. I have 1 sodium here, but I've got 2 on this side, so I'll need to put a 2 here. And then I have 2 hydroxides here, and I have 2 hydroxides over here already. Okay. Now, what I would like for you to do is to pause the video for a second, and you try to go ahead and finish these last 2 equations by yourself. Write the products, see if you can get them balanced, and when you're finished, you can hit play on the video again, and we'll go over them together. Okay, so do that right now. All right, so hopefully you've now finished balancing the equations yourself. Hopefully they worked out okay. We'll go through them here so you can see what the answers should be. You'll notice that in almost every single one of these equations, I have some sort of compound that has a nitrate in it. The reason for that is just because any compound that has nitrates is almost always soluble in water, so they're used a lot in reactions like this just because they dissolve so easily. Okay, so calcium nitrate is mixed with sodium carbonate, so the positive ion here is going to mix with the negative ion over here. So that means I'm going to put the calcium with the carbonate. Calcium's in the second column on the periodic table. It has a positive 2 charge. Carbonate has a negative 2 charge, so this is balanced just the way it is. My other product is going to be the sodium from here and the nitrate from over here. Sodium has a positive 1 charge and nitrate has a negative 1 charge, so it's just going to be NaNO3. Now I can balance. Okay, I have 2 nitrates here, so I will need 2 nitrate groups over here. I have 1 calcium on each side. I've got 2 sodiums here, and I have 2 sodiums here. I have 1 carbonate group on this side, 1 carbonate group on this side. So that one didn't take a whole lot to balance there. All right, last example, silver nitrate and sodium chloride. Silver nitrate's extremely expensive, by the way. So if I'm going to swap partners here, my silver, which is my positive metal, is going to swap and go with my chlorine. So I've got Ag and Cl that go together. Now silver is a transition metal, so how are you going to know what the charge is? Well, if you look at what it's already paired with, the nitrate has a negative 1 charge, so that tells you that this sodium must, or not the sodium, it tells you that the silver is going to have a positive 1 charge. So if the silver has a positive 1, we know that chlorine has a negative 1 because of its column on the periodic table. So AgCl is balanced just the way it is. And then for my other compound, I'm going to put the sodium from here with the nitrate here and kind of have a something that I've had in all of these equations. So we already know the sodium nitrate is NaNO3. And when I balance that, I've got 1 silver on each side, I've got 1 nitrate on each side, I've got 1 sodium on each side, and I've got a chlorine on each side, so I don't need to do anything else to balance that. So as you're practicing these today, a couple things to keep in mind. Make sure that you're remembering the charges on your polyatomic ions, and if you group those polyatomic ions together and balance them as a group, I think you'll find it a lot easier.